This introduction has an audio description. A cartoon of a robot representing Microsoft Copilot appears on screen. The robot waves to the audience.
Can generative AI tools such as Copilot help us to make content more accessible? In this video, I'll cover 4 scenarios I've used this year.
The robot transforms captions into a transcript.
Taking a set of captions and turning it into a formatted transcript.
The robot transforms an image into a text.
Writing alternative text for images.
Another robot labeled Whisper AI appears. Together they transform a podcast into a transcript.
Transforming a podcast into a written transcript with speaker attribution and formatting.
The Copilot robot creates text, images, tables, and graphs.
And generating sample content for use in accessibility workshops. I'll share how you can recreate these scenarios.
The background darkens. Articles about concerns around climate, sustainability, and bias appear above Copilot robot's head.
And touch upon some of the challenges and opportunities of using generative AI.
The background clears. A laptop displaying the presentation webpage appears beside the Copilot robot.
On my website, matthewdprose.github.io, you can find the presentation recording, a list of the prompts I share, example files I used in the presentation, and links to further resources.
The laptop is replaced on screen by a mobile phone displaying the transcript.
You will also find an enhanced transcript of the presentation with images and example videos added so that if you prefer to read the content, you can.
The screen clears, audio description ends.
Let's get started.
Hi, I'm Matthew Deeprose from the University of Southampton. For those who don't see me, I'm a white male in my late 40s and wearing glasses, a navy blue suit with a cornflower coloured shirt and matching pocket square. My pronouns are he, him. Can we harness Copilot and other generative AI tools to increase digital accessibility efficiency? To open the theme of this presentation and put it in context, let's start with a tweet from Madgar Dana posted in 2021. It reads, "Accessibility isn't more work. You were just cutting corners before. The work was incomplete." She's saying that a web page, document, or online service isn't ready until everyone can use it, regardless of any disability or impairment. But for us in universities, many of our colleagues are still unaware of what digital accessibility is, and I'm sure you've heard responses like, "No one ever told me about this before," or "I haven't got time for this," even from our most well-meaning colleagues. And with statutory legislation such as the public sector bodies, websites and mobile applications accessibility regulations in the UK, the latest 22 version I have a screenshot of on screen, and other developments like our Blackboard Universal Standards that set an expectation of meeting a minimum 70% accessibility score for online teaching materials, we have a growing expectation for staff across our institution to engage with accessibility. And for many, this will be more work than they might have anticipated previously. An extra time and resource will not necessarily be allotted for this. Workload is a significant matter for universities. Our university is running a workload principles project which aims to improve the way in which workload is managed, which will hopefully lead to improved well-being and engagement of the university community. Concurrently, our new university digital strategy has a vision to harness AI in ways that are ethical and helpful. So the question is, can we use AI to reduce effort or workload or otherwise increase efficiency with any of the digital accessibility workflows we might expect our colleagues to complete? Today, while I will mention other tools, I'll mainly focus on Microsoft Copilot. And if your institution is a Google shop rather than Microsoft, I expect the Google Claude experience will be similar. Copilot uses a customized version of GPT-4 from OpenAI. As a Microsoft institution, we can log into it with our university account. This gives us a level of protection where our data isn't saved and won't be used to train AI models. Microsoft can't view the chat either, and usage isn't linked to individuals, and our university's identity is removed before the data is sent. And using our institutional accounts, we have 30 responses a day we can use compared with the standard 10. Now on the website copilot.microsoft.com, there are two main interfaces for Copilot. Both can create text and images, but there are some differences between them. The default, which seems just to be named Copilot, is aimed at short questions and answers. As such, there is an 8,000 character limit for the prompts you can write. Microsoft's guidelines say 4,000, but the web page is set to accept 8,000. The main reason to use this variant is we can upload both images or documents up to 1 megabyte in size as part of our prompts. It accepts many types of document format, from standard Office document formats to programming and scripting languages, markup content, LaTeX content, and so on. There's also the option to change conversation style, to switch from diverse to creative to deterministic and focused. Now, this is similar to the temperature parameter you might be familiar with in ChatGPT. Copilot Notebook is the variant I'll be focusing on. Apparently it's designed for rewriting and iterating on prompts that you create. More importantly, for my use cases, it has an 18,000 character limit for the prompts you can enter and can return answers of between 9 and 10,000 characters. And one limitation is that you can only attach images, although there is a larger file size limit of 50 megabytes. So, having set out the context, it's time to review the 4 scenarios for which I found Copilot to be helpful. The first is creating a transcript from corrected video captions. This story began back in January this year. My colleague, Dr. Zubair Shafiq, and I were creating an accessibility video for our doctoral college, and we had broken the content into 10-minute chunks and were working on each separately, which we then pulled together in a final edit. And we've been using a brilliant tool called Subtitle Edit to add, format, and time the captions. And having completed the captions, we wanted to create a transcript. Transcripts have many benefits. Not everyone wants to or can watch a video. A transcript allows more options to engage with your content. And this feedback from a member of our neurodivergent staff group explains this well. They said, "The thing I find most annoying is the way online training is often set up. I don't learn well with videos, flashy moving images on screens, or endless things to click on, to flip or open or whatever. It can get disorientating and it makes it harder to take in the information because of the demands of interacting with the screen. My attention goes on interacting with the screen rather than taking in the information. I'd rather just be given the information transcript style so I can just read it with images where they'll add something useful. I connect information into a whole better when I can see it all in one go. Jump back and forth to double check things and read it, process it at the speed I need to." Now, if the transcript is suitable for publishing online, it may help to improve search engine optimization, bringing a greater audience to your content. And having a transcript can help you to more easily create further resources like blog posts and articles and so on from that transcript source, depending on the context and purpose of your original content. And of course, from an accessibility point of view, as well as being a benefit, depending on the level of compliance we're aiming for, we're required to provide equivalent alternatives to media content, such as a well-prepared transcript. So going back to my scenario, Subtitle Edit has an export text feature to turn the captions into a single block of text. And that block of text is not very readable. While I have the punctuation that I had added when creating the captions, there are no paragraphs, and editing that text to set it into paragraphs is a time-consuming and boring task. On screen, I have a recording of me going through that text and tidying it into sensible paragraphs. It's a slow process, and it would be even slower if I had not written the original text myself. Could Copilot make this faster? I wrote a prompt asking it to reformat my transcript to be more readable. I specified that it could add headings, set paragraph breaks, and use bullet points where appropriate. In my initial testing, I found that it rewrote the text of my transcript, so I added further information explaining that the words and the order in which they appear should remain unchanged. On screen, I'm sharing a recording of Copilot Notebook running that prompt. It is reformatting the transcript as I asked, adding paragraph breaks, headings, and using lists where appropriate. Of course, I had to check the results, and I changed them to suit my preference, but it saved me a lot of time and boredom. The result is on screen. I'm showing a Word document version of the transcript with the navigation pane open to show that I have set the headings using heading styles, so they'll be usable by assistive technologies. A few tips from my experience of making transcripts. If you are the creator of the content in your original video, aim to describe what is happening on screen as much as possible. This should help you to avoid the requirement of a separate audio description of any unvoiced but important action. It should also make your transcript more meaningful to those who are reading it. For example, rather than saying, "As you can see, the graph shows we have a significant number of students who disclose a disability," you could say instead, "Over the past 5 years, around 1/5 of our students have disclosed a disability each academic year." Transcripts can be more useful if you add hyperlinks to other websites or documents that you reference in your original media. And again, while not a requirement, if you add relevant images with appropriate alternative text, the transcript will become even more useful, especially for those who just prefer to engage with content in written form over video. Next, can generative AI help us to write alternative text? What is alternative text? You may hear alternative text shortened to alt text. I'm likely to use these terms interchangeably. To me, they mean the same thing. It's the written description of an image that we write for those who do not see it, helping them to get the intended meaning of that image. This might be those with visual impairments who use a screen reader and assistive technology that speaks aloud what is on screen. Alternative text benefits those who personalize their learning experience using alternative formats from Blackboard, such as the audio version. And those who listen to content rely on alternative text being provided for images, otherwise they'll miss out on important details. Alt text also appears when an image link is broken or users have turned off images. Those on pay-as-you-go internet may disable images on web pages to save bandwidth or data costs. If alternative text has been added, they won't miss out. A report last year from JISC found that around a third, 34% of UK students had problems with mobile data costs. And when we don't add alternative text to images, we're creating a barrier for those who do not see them. And when we write alternative text, we should consider the context in which we use the image. We should consider our intended audience, who is our target reader or listener, and what is the function or purpose of that image. We may write different alternative text for the same image when we use it in different contexts for different audiences and depending on the purpose of the image. While the general recommended length for alternative text is about 2 sentences, when an image is more complex, like a chart or graph, we may need to write a longer description of the image. I use this guide to explain when we may need to write a long description for an image. So if we're just using the image for visual interest, we'll mark it as decorative. If the image replicates text already in the document, then we should add a caption describing the essential content and context and use the alt text feature to mark the image as decorative. If the image supports or rationalizes what is in the text, then we should write a brief alt text describing essentials of the image and use a caption or title. And if the image goes further than what is in the text, or I want students to use the graph in some way, then I should write a brief alternative text describing the essentials, add a caption, and then provide a full description elsewhere in the document. Ideally, I should also provide any tabular data that was used to generate the chart or graph if my image was one of those. Back to the matter at hand, our colleague Dr. Terendu Lianagunawardena, Digital Accessibility Officer at University of Reading, shared with me a few months ago this image accessibility creator tool from Arizona State University. This tool allows you to upload an image file. It will use the GPT-4o model provided by OpenAI to create a long description, a short alternative text, and it will list any words it can detect in the image. You can also provide further information about the image to help it write a better description. With this detail, we may have all the information we need to create a suitable alt text based on our earlier considerations. On screen, I'm demonstrating how, having uploaded a cartoon image of a cat sleeping on the dashboard or cockpit of a spaceship, it describes the image impressively, sharing all the details, colors, and mood of the image. Because ASU are using OpenAI's Application Programming Interface, or API, images are not kept or used by OpenAI. The ASU tool is really impressive, and it's currently open to anyone to use. But since it may be put behind a login at any time, I worked on a prompt to get Copilot to give just as good an answer. The prompt I have is based on one that Purdue University shared, and I've fine-tuned a little. I'll read out the prompt. You are a university-level instructor working to ensure images in your online course materials conform to Web Content Accessibility Guidelines to Level AA. You need to accommodate for disabilities and impairments, such as blindness, low vision, and colour vision deficiency, to ensure equitable access to module content for all students. You'll be provided with an image. Please return a succinct title, alternative text or alt text, and a long description. You will also separately list verbatim all words that appear in the image. The alt text should be no more than 2 sentences and should briefly describe the meaning conveyed by the image. The detailed description may be 1 or more paragraphs and must describe the image in great detail so that anyone who does not see it can gain a full understanding of everything in the image. Please format the detailed description such that it will be easily scannable. Use headings, paragraph breaks, and lists as appropriate. I also recently added use active voice, use UK English, because I noticed it would often write in passive voice. Active voice aids understanding. And by default, Copilot writes in US English, so I want it to write UK English. This is just a generic prompt. We could tailor it for each image based on the context, function, and audience for that image. And while this gives slightly better results in terms of formatting, the ASU tool is a lot faster. Let's review the strengths and weaknesses of Copilot's image descriptions with 3 example images. On screen, a line graph shows the percentage of full person equivalent students disclosing a disability at the University of Southampton from 2019-20 to 2023-24. Between 1/5 and 1/6 of students disclosed a disability during this period. Our Copilot gave a pretty accurate title of Student Disability Disclosure Rates at the University of Southampton. I did have 2 issues with the alternative text. It correctly identifies it as a line graph, but it says it's about full-time equivalent students rather than full person equivalent. And while it says that the amount is increasing over time, it would be better to give us an idea of the proportion of students. The long description is broken into sections for a general description, details of the graph, and an examination of the data points and trend. It makes the same error around full-time equivalent rather than full person equivalent students. It describes the axis of the graph in detail, which for this graph, I don't think is really necessary in the context for which I was using the graph, but that's still for me to judge. And for the description of the data points, it adds words like approximately around the figures, which may not be necessary. Still, I think it's a good start, which could be quickly reviewed for accuracy by the author who will use this graph. My own alt text would be very similar, line graph showing percentage of full person equivalent students who disclose a disability at University of Southampton. Between 2019 and 2023, the proportion remains between 1/5 and 1/6 of students. And for the long description, I set out the result for each academic year as an unordered list. This semantic detail will make it easier to anticipate and review the description for someone using a screen reader. It would also be easier to visually scan for readers as well. So for example, I have academic year 2019-20, 16%. Last week, a new feature of the AI Alt Text Assistant was launched for Ally. I've turned it on in our testing environment, and for the same graph, it gives the following suggested alternative text, a graph with numbers and a line. My next example is a basic diagram of the process of photosynthesis aimed at school children. Copilot's title is fine, photosynthesis process diagram. The alt text is also pretty good, a diagram illustrating the process of photosynthesis, showing how a plant takes in light energy, carbon dioxide and water to produce oxygen and sugars. However, when I show you my own description, I'll highlight how I could make it a little better. For the detailed description, Copilot produced an overview, a section describing the visual elements, and a section covering annotations and labels. I won't read out the whole description, which you can find in the slide deck, but I will point out a few aspects of the description to examine a little further. The description of the ground being brown, the sky being blue, and so on aren't necessary for the purposes of this description. And in this way, it is explaining the annotations and labels. For example, the roots are labeled water H2O, indicating absorption from the soil. That could be described in a simpler way, as I'll cover in my own description. So while my alt text is 3 sentences, I'll probably keep this as alt text and not write a longer description. My description is process of photosynthesis. The plant takes in water through its roots, carbon dioxide and light energy through its leaves. The leaves release oxygen into the air and generate sugars as part of the process. In this way, I believe I've covered the essential information in this diagram without getting into the nitty-gritty of describing labels and arrows or colours. Ally's AI Alt Text Assistant gives the following suggested alternative text, a diagram of a plant with text and images. The final example is one suggested by my colleague P. Borman. It's a chart comparing lengths of selected rivers and heights of selected mountains from General Atlas of the World, published in 1854. Along the top of the image are depictions of rivers like the Yangtze, Volga, and Ganges, with their lengths listed in miles. And towards the bottom are hills and mountains of different regions and their heights measured in feet. Copilot suggests a good title, 19th Century Physical Geography Map. The alt text describing it as a 19th century physical geography map, providing a cross-section view of various geographical features, including mountain ranges, plateaus, and rivers, is pretty good too. Copilot broke down the long description into parts, which I'm sharing across 2 slides. I won't read out everything on the page, but you can refer to the slide deck for this detail. The structure of the long description is an overview, followed by descriptions of the top, middle, and bottom sections of the image, and a commentary on the relevance of the image. A big mistake is at the top section. It describes it as representing rainfall measurements rather than rivers and their lengths. And the long description continues with an overview of the different sections. And while the general description is okay, it gives specifics that are not actually in the image, like mentioning Mount Everest and the Plateau of Tibet. So it looks as though Copilot is confabulating these details. It has generated plausible sounding but potentially inaccurate or fabricated information. What did Ally's AI Alt Text Assistant suggest? A map of a mountain range. So what lessons and tips can we draw from this? The images I used were all troublesome in one way or another, and in my experience so far, images like photos or pictures like the illustration of a cat sleeping in a spaceship that we saw earlier work better. But I wanted to use images of the type we're more likely to use in higher education. I think that Copilot and similar tools can help us to go on to write better short and long descriptions by presenting the structure of the long description that we can then improve, or by adjusting a description to make it relevant to our context, audience, and purpose. The generic prompt is just the start. It could be fine-tuned, or we could add follow-up questions. Of course, we need to consider bias and confabulation, particularly if the description infers meaning or content that is not in the image. And I can see that using AI to create descriptions may frustrate colleagues into just doing it manually, as they get better understanding what makes good alt text. As ever, subject matter experts should be writing or reviewing the descriptions, however they have been initially created. And there's lots of resources out there to help write image descriptions. I particularly recommend Described from Textbox Digital, the Complex Images Making Sense for Accessibility site, and the NWEA Image Descriptions for Assessments. Textbox Digital's Described service provides guidance and worked examples of writing alternative text for different types of image. On screen, I'm listing the types of image they cover. Examples include diagrams, graphs, maps, and scientific images such as circuit diagrams. I'm now showing a list from this scientific section. This includes astrophotography, chemical element notation, and other scientific image types. And when you select an image type, Describe provides an overall set of guidance, a step-by-step process, and a worked example with a final complete description. Once you have a process you can follow, it really helps you to unlock what once might have been a mystery and can make it seem simple. On screen, I have a screenshot of part of the explanation for describing circuit diagrams. In our third scenario, we're going back to transcription, but from a different angle. And this one is a bit more of a work in progress. The Meliora podcast from the Sustainability and Resilience Institute at the University of Southampton examines topics surrounding sustainability. On screen, the podcast is advertised in our internal University Staff Matters newsletter. However, one of our colleagues in our communications team who writes the newsletter is profoundly deaf and cannot listen to the podcast. She and the podcast host, Professor Simon Kemp, got in touch with me to ask what options were available to make transcripts for the podcast. Simon has a small fund for paying students as casual staff to edit the podcast, but has no extra funding to pay someone to make a transcript. Since the podcast is an MP3 file, what tools did we already have that could help make a transcript? We use Microsoft Stream, but it can only create captions for video files, not audio files. Converting an MP3 to a video file would work, but it requires additional software. I came across Whisper Desktop. It's a Windows open source application designed to run with the open source automatic speech recognition system Whisper created by OpenAI. And if you have a good graphics card, this tool can run on your Windows computer and transcribe audio or video files, or live speech captured through your microphone. It can output that transcription to caption files or plain text. It supports 99 languages and it can translate between languages. And during transcription, you can view a live preview. On screen, I'm sharing the preview while it transcribed one of Simon's podcasts. It's showing the words it has detected. Each word has a colour going from green to yellow to red. The colour indicates its confidence for accuracy. It took about 9 minutes to transcribe an hour-long podcast on my work computer. The transcription has a good level of accuracy. Unlike YouTube transcription, you do get punctuation. As an aside, having confidence levels, the transcription might be useful for our lecture capture recordings. If we could focus on words with low confidence levels, it might make caption correction faster. And just like in our first scenario, we have a big lump of unformatted plain text, not very readable. And in this podcast, there are 5 different speakers. Can we get attribution added so we know who is speaking? So I wrote a prompt for Copilot. I gave the speakers names and who is the first speaker. I asked it to write the name of the speaker followed by a colon in bold formatting to appear before each person speaks. I'm asking it to do this based on the text transcription, not the audio file. On screen, I'm sharing a screen recording of Copilot going through that task. It is adding the name of each speaker in bold before they speak. It would be great if we could add the formatting details like headings, paragraph breaks, and so on that we saw in our first scenario. I have another screen recording showing Copilot reformatting that transcript with the speaker attribution added. It's using headings, bulleted lists, and so on. I did try asking Copilot to do speaker attribution and formatting with a single prompt, but I found the results to be much worse than doing them separately. So now I'm showing the before and after, our initial block of plain text in comparison with a transcript that has headings, more meaningful paragraph breaks, bullet points, and speaker attribution. It's definitely not perfect, but it would take someone much less time to fine-tune and correct this transcript using our adjusted version in comparison to our original block of text. And so far, this is just a proof of concept. In my testing, I had an 18,000 character limit for what I could ask Copilot. It would not give me an answer longer than 10,000 characters, and podcast transcript was 60,000 characters long. I'm hoping to discuss with my colleagues if there's an opportunity for us to use the Copilot API to break these limits. And ultimately, could we create an endpoint where a user could upload the MP3 file, have Whisper create the transcript, and Copilot format it, rather than requiring them to do multiple separate steps? I think the creation of an end-to-end solution like this could help because it is a good story to tell, from our profoundly deaf colleague being unable to listen to a university podcast to an AI-based solution that can help to create a readable transcript with a much lower level of human effort to correct and adjust the final transcript. The final scenario is around creating what I call sample content. I'm meeting teams around the university who want an introduction to digital accessibility. We have online training available, but meeting teams and discussing accessibility within the context of their work with examples to work through can be quite effective. I've also found it's better not to use real-world content. If we don't approach this in the right way, colleagues might feel that their content is being singled out, but creating example content that is more meaningful than a chunk of lorem ipsum placeholder text can be a challenge. I'll be working with a group of project managers and analysts soon. I asked Copilot to create me a project update document for a fictitious project that aims to make project managers more efficient by using cats. I stated that the document should have an overview of the project's aims, red, green, amber ratings for time and cost, a list of deliverables, and a roadmap. I could then adjust the content it gave me by adding some accessibility issues myself that the group could remediate while we covered the topics. On screen, I'm browsing through my document. I've added defects like aspects of low contrast. I've made the red, amber, green rating use color alone to express meaning. I've got a table without the proper headings, poorly crafted links, lists without list semantics, and so on. The content itself is slightly facetious, but I've avoided using real-world content. I've avoided using lorem ipsum placeholder text, and I've got elements that would appear in a project document. And it took 10 minutes altogether to create. At the end, I added an image that I asked Copilot to create of a project manager being assisted by a cat. Copilot will always give you a choice of 4 images, but on my original attempt, it gave me 4 white male project managers, perhaps an example of bias within the model. So I adjusted my prompt to specify the gender and ethnicity of the project manager. Now I'm going to draw us to my conclusion. Of course, we must consider the sustainability of AI tools as we face a climate emergency that will have an unthinkable impact on our lives within the next 20 years. The climate stripes image by Professor Ed Hawkins shows global temperature rise over nearly 2 centuries. Each stripe represents a year's average temperature relative to the overall period. Blue stripes indicate cooler years, while red stripes show hotter years. The deep red stripes on the right highlight recent rapid warming. A single generative AI exchange can consume the equivalent of half a litre of fresh water for data center cooling and consume 100 times more energy than one Google search. Understandably, there is a great deal of concern around the impact of AI on the climate. A post in Disconnect blog titled "Generative AI is a Climate Disaster" explains that Google and Microsoft's emissions are increasing between 30 and 50% despite their goals to be climate neutral by 2030. And bias has long been a concern of generative AI. I have some recent news articles. First, that University of Washington found that ChatGPT was biased against resumes with credentials that implied the applicant had a disability. A recent paper from Cornell about the biases in generative AI, and a recent blog post by Balder Bjarnason comparing generative AI with asbestos. Balder explains that just as asbestos use was rationalized as having positives that outweighed the negatives until it was banned in the US only this year, that generative AI is in that same position, promising some benefits with advocates either ignoring the negatives or saying that the positives outweigh them. Some challenges and opportunities. These are more open questions for institutions to consider than answers. Different answers from Copilot to the same question can occur due to model changes, e.g. switching from GPT-4 to GPT 3.5, adjustments to the model, or slight variations in punctuation or spelling in our initial question. Is reproducibility important? How do we explain this to users? Likewise, the tools are changing frequently. In the weeks between me starting work on this presentation and today, both ChatGPT 4.0 Mini was released, as was Ally's AI Alt Text Assistant. The best scenarios involve manipulating text and using prompts. To mature these solutions, we might provide more turnkey options, possibly using local large language models. Copying and pasting prompts into a browser is still immature and not necessarily user-friendly. All of the scenarios I've looked at today are about reducing effort and time, but verification and completion by a subject matter expert are still required. There is rightfully a lot of anxiety around AI, particularly in terms of the ethics of how large language models are trained, their sustainability and impact on the climate. Can we account for our carbon usage of generative AI just as we do for university buildings and travel? And finally, among all of these challenges and concerns, I think that positive uses of AI to remove accessibility barriers is a good story to tell that may help to gain buy-in from university stakeholders, both toward digital accessibility and using AI to reduce the digital accessibility workload. I hope that by sharing these simple ideas, we can continue the conversation and learn from each other about your ideas and uses for generative AI that help us in our digital accessibility work. I really want to learn what others in our community have been doing. And at the end of the slide deck, which you can download, you'll find links to everything I've referred to. Thanks for listening.